Okay, well, I'm going to continue, but instead of talking about language, which you just heard in the previous two talks, I'm going to broaden this a bit and talk about children paying attention to the gestures and actions of other people. And I want to try to show you, as the title of the talk is, that children are really wired for learning from the culture where they're brought up. And part of that is their intense interest in imitating socially the people they see around them. This is implicit learning. They are not being trained to do this, but they quite naturally imitate, copy the people in the world. They want to be like us, and there's obviously some very interesting neural machinery that supports this that we'll begin to talk about. They use imitation not only to learn about the actions in their culture, the culture rituals and mores and ways of behaving in the culture, but also the way that people in the culture use tools and machines, how to use a simple lever, how to act on objects in the world. So they're both learning about actions and goal-directed acts on objects. Also, as John mentioned, the intentions of other people, not just what they did do, but what they meant to do, are things that babies pay very careful attention to. Now, I know that not everybody here has seen films of very, very young babies in the laboratory that we have upstairs here in iLabs. We see about 5,000 children a year, and I want to just show you a 30-second clip of a 1.5-year-old in an imitation study. This is a child sitting across the table from me when I do a somewhat novel gesture of taking a camping cup and squashing it. She looks at the object up at my eyes, then we give it to her, and she turns it over and does exactly the same thing. Then, in order to test imitation, really look at novel imitation, we had the adult do something strange, like touch this object with his forehead. She's never seen anything like this before. Do you want to turn? And she imitates. So human infants have a real drive to act like the others they see. And all of you in the room will recognize that this poses a very, very interesting neural problem about how the machinery of a young child can take the perceptual information and translate it into a like matching action themselves. Imitation, of course, does not just start at 1.5 years. It starts earlier. Children are literally wired to learn from culture. They're born learning. And I did a study with 19-hour-old babies in a hospital setting. This is a 19-hour-old baby looking up at a human face. You can see how interested they are in the human face. Then the adult sticks out his tongue. The little baby's eyebrows raise, and she, 19-hour-old, looks at this strange biological movement, and she responds with tongue protrusion of her own. When the adult switches to mouth opening, you can see her eyes again converge and look at this strange biological motion, not just paying attention to the human face, but the particular moving internal details, and responds with mouth opening of their own. So this is really a very, very interesting thing to occur in a 19-hour-old. We obviously published papers showing even younger than 19-hour-olds, just because developmental psychologists like to set world records about this. The youngest child I tested was 42 minutes old at the time of birth. We had gotten permission from the mother who was on the hospital ward pregnant the night before, and we said we really wanted to be the very first person that poked out their tongue at the baby because we wanted to know if it was innate. And there to begin with, the mother said, well, I've had 3 other kids. Why don't you come in and film the whole birth? And you can be the first person to do this. So we published a paper with 42-minute-old babies imitating tongue protrusion and mouth opening. This is really interesting because the children have never seen their own face in their life. They can look up and see the face of somebody else, but there are no mirrors in the womb. They haven't seen somebody else's face prenatally, and they can't look down and see their own face. And yet, at birth, the human infant is able to take the visual information, the perceptual information, and translate that into a matching motor gesture, and that is very important. We'll talk about that. Emotions also play a role in children's imitating. Infants are not compelled to imitate. They can regulate their imitation. They have some inhibitory control of that. And emotions plays a role, at least in slightly older children. I've done this work with Betty Rapopoli, and we did a study where we had, I'll show you a film clip, we had an adult experimenter show a gesture on an object, use a stick to press a button that made a sound. And we knew from other studies that we published that if you then give the baby the box and the stick, they will imitate with great joy. They'll pick up the stick as a tool and make the box work. But we had an adult emoter watch the first adult as the adult did this action, and the emoter acted very angry as the baby watched wide-eyed and said, "That's very annoying," as if this was a forbidden action in the culture, like putting your finger in a socket. The other adult criticized the first adult. The baby watched wide-eyed, and I want to show you what the baby did. So here's an 18-month-old watching.
See? Look at this. There.
Now we know from pilot studies she wants to grab that stick and do it.
Hi, Barrett. I'm going to sit here and read a magazine.
Okay, that's Nina. Nina's going to sit and read a magazine. Nina, look at this.
That's aggravating. That's so annoying.
Oh, I thought it was really interesting.
Well, that's just your opinion. It's aggravating.
Okay, I know that doesn't happen in your household, Christoph. It does happen in Seattle. Now, what does the little 14-month-old make of this? We give her the stick. Looking up at the adult. The adult is sitting there with a neutral facial expression at that point, not showing the angry face, but the baby remembers that that adult is looking at her, had been angry when the other adult did the action. The baby won't do it. There's many hypotheses about what's going on. Two of them that were of interest to us was that baby just frightened because there had been a negative emotion and she was paralyzed into no action, or was there something more sophisticated going on, which is what I thought was happening? The baby remembered that that person was angry and thought that that person might be angry at her if she did the action. The way we separated that is we had the emoter make the same negative facial expression, negative tone of voice, and then the adult got up and left the room. So baby had the same emotional reaction, but the adult wasn't there anymore. We gave the baby the object. The baby peered out the room to make sure the adult was gone, picked up the stick and began buzzing it. So it didn't seem like your teenager might. It didn't seem that it was just fear in the baby that was there. So what we wanted to do is leave the adult's body in the room, but not have the adult watch the baby to help segregate further what are the controlling variables. And this is a study that we did, another 18-month-old on the bottom here, where the adult got angry in the same way, but then just turned around so she couldn't look at the baby. So her body was in the room, but her attention, social attention, was no longer on the child.
Hi, Barrett. I'm going to sit here and read a magazine.
Okay, that's Nina. Nina's going to sit and read a magazine. Nina, look at this.
That's aggravating. That's so annoying.
Oh, I thought it was really interesting.
Well, that's just your opinion. It's aggravating.
So Nina turns around then, and we give the toy to the baby. So Nina's body is there. She had been just as angry, but Nina is no longer observing the child, who at this age can know when she's the center of somebody else's attention and is integrating information about that person's past emotional state, we think. We're very interested in the neural correlates of this. Wouldn't you love to have that little baby who was inhibiting her action, the first one I showed you, in an MEG machine while she's looking at the adult and not doing the action, controlling it? It would be very interesting, and those are some of the social neuroscience studies that we're interested in doing. At the moment, we have been using EEG with Peter Marshall, a developmental neuroscientist, obviously looking at mu rhythms desynchronization, and we published 2 papers of this just in the last 6 months that we think are very interesting. We were able to show significant mu rhythm desynchronization, especially in central electrodes, when the baby is either executing the action, as you might think, or just observing the action in someone else. So this is our beginning looking at mirroring mechanisms from a neural point of view, just beginning to do that, obviously wanting to use MEG in the future. Now I want to skip to gaze and learning because eyes are very, very important for adults, but also for children. And they're important for children because adults point out, as it were, important information hotspots where to learn things in the world just by where they are looking. Children's gaze are brought to these information hotspots because adults use them when they're taking a walk. They say, "Oh, look at the dog," to their baby who might not know what the word is but can help decode the meaning of the word by where the mother's looking and what she's saying. Also important for emotional learning, because you usually don't express emotions just about nothing, but because you've seen something in the world and are fearful or horrified or pleased. The child looks at your face, looks at the object, and helps decode the meaning, or the referent at least, of the emotion by paying attention to gaze. So we've done some studies about gaze following. Many people around the world are doing this. I just wanted to show you in our laboratory. Here's a 12-month-old baby sitting across from an adult. There's two inanimate and silent objects, one on either side. The adult then randomly looks at one of them. The baby looks at her and then looks at the object where the adult is looking. And the adult can look from one side to another, and we can show scientifically that the baby will follow the adult's line of gaze. We know something about the controlling variables because if the adult closes her eyes and then makes the same head movement, the child does not follow a line of regard. Same thing if the adult wears a blindfold at a certain age, they will not follow a line of regard. So they're looking where the adult is looking, not just where the head is moving toward. But whose gaze, what constitutes a psychological agent, and whose gaze do you follow? Children don't follow everything in the world. If you open a door and the doorknob moves, the babies don't follow the gaze of sort of where that object is pointed. So we're using robotics to help address this. And if you just have a child look up at this robot, when the robot turns to the side, they will not follow the gaze of the robot. It's like it's a hunk of metal, and it's just a block on a stick. And the child watches where the block is moving, leans forward and watches, but does not project out in space to where the robot has turned. But we wanted to figure out what would constitute an intelligent agent, a psychological agent to a child, and how to endow this with some intentionality. And what we hit upon was have the baby watch as the adult and robot engaged in an imitative interaction. Because I think children know from their own experience something about imitation and regard it as a communicative interaction. So I want to just show you, this is what the baby watched.
Oh, yeah. Can you do this? Oh, yeah.
So 18-month-old children watched the robot engage in an intelligent way as if it had sensors, so it could determine what the adult was doing. And then the child looked, we had the child in front of the robot. The child sat in front of the robot turned its head, and then the child turned its head. And we, of course, had control groups where the robot made exactly the same motions, but was not communicating with the adult. The adult just stayed stationary, so it wasn't the movements of the robot. And we even had a control condition where the adult made the same movements as they did in the imitative condition, and the robot did, but they were out of sync, so they weren't having a good communication. They were out of sync, but both entities made the same motion, and the children did not gaze follow then, only if the child watched the robot engage in an imitative or communicative interaction. We're now beginning to do a whole lot of work on social robotics, where we're trying to use the fact that the children are using gaze following from learning to get robots to follow gaze and robots to learn from imitation in the same way that biological entities do. Lastly, I want to just bring this to school. Some of the ideas about imitation and social learning that I just talked about play a role in children's adjustment to school. You know, children are born learning, and schools are designed to teach, but something sometimes goes wrong, and we've been wondering what that might be for children. And one of the culprits, we think, has to do with stereotypes held by our culture. I want to explain that in a moment here. In American culture, and many cultures around the world, but it is not culturally universal, there are stereotypes that boys do math and girls do reading, that girls don't do math. And people have wondered, does that have an impact on children who are so socially attentive in the way that I showed since infancy? Here's some data, unfortunate but true data, that at least in America, the scores on math SAT tests over the past 20 years, men have outscored women significantly on SAT tests on math. And so that leads to the question, obviously, a very charged question about whether this is an innate aptitude difference or cultural influence, and without denying at all that biology may play a role, given the baby's social attention, their attunement to others, their ability to imitate others, absorb information from the environment, we thought that cultural messages might really be making a difference here and did some studies about that. Media carries a lot of stereotyped images about this. Here are some images that you might commonly see in magazines about boys doing math and images of girls doing reading. And so for our study that we did with elementary school kids, 1st through 5th grade kids, we made 3 conceptual distinctions, and I'll show you the study. The connection between male and self is what's called in the field gender identity. This is different than the link between male and math, which is a stereotype that might be in the world, between males as a class and this domain, mathematics. And then the link between math and self is a self-concept or identification with a domain. It could be self in computer science or any other domain. So if you keep these conceptual distinctions clear between gender identity, stereotypes, and self-concept, you can look at developmentally the interplay among those. And we designed a study with 1st through 5th grade kids, which led to some very interesting results. We adapted a social psychology procedure called the Implicit Association Test, IAT, that many of you may have heard about. We developed a child IAT test that we were able to use. And the test has to do with pressing computer keyboards, but I'll just simplify it, imagining that we had buckets here, this one for female and this one for male. What we essentially did is ask children to sort objects to go into the female or male buckets. And this is what we found. If we gave these elementary school kids book, they would look back and forth at the buckets and then put book in the girl. Then we'd say numbers, boy. Addition, boy. Math, boy. Graph, boy. Story, girl. Letter, girl. By 2nd grade, which is before they've learned their multiplication table, horrifyingly, American kids have the world, the social world, sorted out into stereotypes that boys go with math things and girls don't, and this is before they've even learned multiplication tables. So here's the results that we found, actually, but the gender identity, I'm a girl, developed quite early. Girls don't do math, developed by 2nd grade. Children showed evidence of this. And then by 3rd grade, they had, as it were, internalized the external stereotype. Girls in general don't do math. I'm a girl. Girls don't do math. Therefore, I don't do math. It's as if they have a sort of a social algorithm in their head. And given the 2 pieces of information that they absorb, I'm a girl, gender identity. Girls in general don't do this. Therefore, to keep what's called cognitive consistency or cognitive balance in social psychology literature, they draw this conclusion. And that's not necessarily true across the globe. My postdoc, Dario Savenchek, just came back from an interesting study in Singapore where we're analyzing the data. Singapore is a very interesting culture to do this because Singapore kids in general outperform American students in mathematics. And the boys outperform American boys, the girls outperform American girls, but it's really very interesting. In Singapore, the girls outperform the boys in mathematics. And so we're very interested in the stereotypes in that culture and the link between the children's self-concept and their performance on mathematics. So from a theoretical point of view, what I want to argue is that children are obsessed with what are like-me entities in the world. Who out there is like me, and doing the mapping between self and other. During infancy, we see this where they imitate another person's motor behavior. But for older children, it's not simply the imitation of motor behavior or even the intentions of others, but they take on the attitudes and attributes of another like-me group. Children establish a like-me class like gender. I'm a girl, there's girls out there. And there are other ones, a certain race, and there are people of a similar race out there. The way the culture treats others who are like me influences kids' interests, goals, and aspirations for themselves in the future. Identity formation, this formation of the like-me class, is critical for motivating learning in and out of school. We know how much they're paying attention to peers, and we're trying to track this and look at individual differences in imitation early and see what it predicts later. So there is ubiquitous social learning. Infants are watching us. They implicitly are learning from us, not just what we do, but what we say. The neural machinery underneath this is quite interesting. It leads to a mapping between the gestures and actions they see, mapped onto like-me entities. And what we're very interested in is the developmental neuroscience that can underlie this. With new tools, not only EEG, but MEG, we want to have newborn babies, or they'll be in our MEG machine, so they'll be 3 weeks old, sitting across from a human face, poking out the tongue. What's going on in there when the little 3-week-old is watching and was responding? What's happening when they're inhibiting their imitation due to emotions? We're interested not only in what's going on in their brain, but also looking at predictions. Some of our imitation studies have already shown that if we take measures of imitation of the type I've shown you at 2 years of age, we can predict severity of autism when the children are out at 5 and 6 years of age. That's new research that we have that we're really very interested in doing. And another one on the emotion study, when we find children who are very good at inhibiting their actions at 18 months, we think that's related in a primitive kind of go, no-go way to executive function. And we're now correlating the children's ability during the first years of life with their executive function abilities later. So we believe that looking at the neuroscience and prediction in typical and atypical will be very interesting. Okay, thank you.
Thank you.